Hey everyone, and welcome back to the SaaS developer community when we learn how to build SaaS applications from each other. And I have a special guest today. I have Andrew Wang from Airtable, where he's leading the storage engineering team.
Mm-hmm.
And previously, many years ago, I think over 10 at this point, we worked together at Cloudera, where he was on the HDFS storage team. So at least a decade of experience building scalable storage, I guess.
Yeah, that's right. Yeah, Gwen, thanks for inviting me onto the show.
Yeah, so the reason I invited Andrew is that I've read a blog post, and it was on our Hacking SaaS newsletter a few weeks back. I read a blog post about how he and his team at Airtable migrated their database, their distributed large-scale database, from MySQL 5.6 to MySQL 8.0. And it was fascinating. So I'm like, okay, I have to talk about it. And we're not going to talk about every single detail, so you still have to go read the blog. But I have a lot of questions, and I invited Andrew to discuss. So let's get started. First of all, just as a high-level overview, what makes writing a storage layer for Airtable so unique?
Yeah, I guess first off, a bit more about Airtable. We are a low-code, no-code application development platform. So our objective is to allow our users to build custom applications tailored to their different business processes using the tools that we provide. And sort of at the core of our platform is actually our own custom in-house relational database engine. So we have an in-memory database that we've built on top of other technologies like MySQL in Node.js that powers the Airtable interfaces. So this is kind of a unique thing, I would say, because there aren't too many databases that are designed for these kinds of use cases of sort of like, let's say, human scale data on the order of 100,000 or maybe low millions number of rows. So I think the cool thing about this compared to other sort of similar applications is that we support a lot of operations that are just not available in a typical relational database. So one example is we have support for things like formulas, attachments, so like sort of big blob data, things like that.
So it's basically a database with a bunch of Excel sprinkled in, or Excel with a bunch of relational database things sprinkled in?
That's sort of how the product originally started, but now we've moved, like, I would say, well beyond that with the introduction of things like automations. So we actually have the ability to trigger little bits of computation based on actions that are happening in your database. Like when a certain cell value changes or a row is added, we can like send a Slack notification, for instance, or send an email, or talk to some other external system. So that's pretty powerful.
It
and
is.
we also allow like developers to users to build their own custom interfaces on top. So you actually have like custom like UIs designed tailor-made for certain business purposes. So you can really customize like how people interact with your Airtable base.
Got it. Yeah. Yes. And you own the storage layer driving the whole thing. And then in your blog, you kind of showed what the data layer looks like. And it's probably one of many data layers. But so basically what I've seen is that you have this main shard for things that are not in specific bases, which you'll have to explain bases. And then you have a bunch of shards that presumably each one of them has one or more bases.
Yeah, exactly. So I mean, at a very high level, we have like two types of data, base scope data and non-base scope data. So base scope data is basically all those like little relational databases that are owned by our users. So, I've built some application on Airtable. The data is what we call a base, and that data is stored on a base shard. Our non-base scope data is sort of like everything else. So like user scope data, workspace scope data, enterprise scope data, all of that goes on our what we call our main shard, which is one big MySQL instance.
So each base is basically kind of an Airtable application. Is that the way to think
Yeah,
about it?
exactly. It's on the
Got it.
order of, let's say, again, a few million rows and a lot of accompanying metadata. So all said in at the MySQL level, we have, let's say 100 megabytes or maybe a gigabyte of data per base.
Yeah, okay, that makes sense. So let's dive a bit more into how shards and bases are managed. So you wrote, and I think it was kind of like this byline sentence that I'm like, how did they do that? That you have pretty sophisticated tooling around mapping bases to shards, and if someone gets a bit noisy, you move them to a different shard. I assume it's all homegrown. Like, can you share a bit about how you do that?
Yeah, this is our own application level sharding mechanism on top of MySQL. So the way it works is that we have, at this point, 100 plus base shards, each of which are an independent MySQL instance. And that means we have millions of bases living on each shard. The way that we do routing or assignment is actually quite simple. So I mentioned before we have like these two main clusters, like the main shard and like also our base shards. We actually store essentially a big lookup table on the main shard. So when you have like your application, you have like a base you want to access, you first go to main and say, here's the ID for my base. What shard does it live on? The main shard tells you, and then you can go to that corresponding database to access your data. So it's a very simple system, and it works because we have, again, on the order of, let's say, tens or 100 million different bases, which is not that many to have in the lookup table in the MySQL instance. So it's simple, but it works. We've also built a bunch of tooling that helps with like the operational aspects of running this sharded base cluster. So Gwen, you sort of already alluded to this, but like some things that we do are that we sometimes move bases around for like load balancing purposes, essentially. Or maybe we have like certain tenants that are like really important or really hot in terms of their usage. Might need to shift these bases around our base shards to sort of spread things out. And this is done by using what we call our base transfer process, which is like an operational tool that we can trigger to basically move a base from like shard A to the shard B.
And that's something that happens automatically in the background, or does someone get paged at midnight and has to click move from shard A to shard B?
That's a great question. So right now, this is a manual operation, but the good news is that it doesn't happen that often that we need to trigger a base transfer. I'd say the main use is that we've made recently of base transfer is sort of for our own operational or testing purposes. So we actually have to talk about this during in the blog post, but one thing you might want to do is when you're provisioning like a new version of MySQL, you might have just one new shard on that new version, and we move like some kind of internal base or a testing base to that shard. So you have just like one like very small workload that's an internal workload sort of running against this new version. So that's like a very useful thing that we can do with our base transfer process.
Yeah, I thought that was one of the coolest ways. It's like a blue-green deployment, but for databases, which is not something you see all that often.
Yeah, definitely. Yeah, I'd say like that's like definitely one of the big benefits of our database architecture with sharding, where since we have like 100 plus shards, we can make changes on just one shard, and either it only impacts like 1% of our workload, or even just like the specific bases that we're putting onto that new shard.
Do you also manage things like backup restore of individual bases in case someone kind of calls you and asks for their data back? Yeah. So you do it the same way? You kind of restore something on the side and then redirect?
Yeah, I mean, this is like a great, like classic sort of DBA question, asking about backup and restore for like a database, it's sort of like table stakes when you're running like, something like MySQL. So, we do run on the RDS, and RDS has built-in support for backup and restore at the MySQL level. We've also built backup and restore at the Airtable base level. So you can imagine, again, our users are essentially their own DBAs in some sense. And so they want to be able to like, undo changes, maybe go back to like yesterday's version of the base if something really bad happens, just classic like, use cases for why you might want backup and restore. And we do support that in the application.
So this is all part of your product,
This is
essentially.
all part of our product. Yes, we have backup and restore and like undo basically. So you can go into Airtable and you go Command Z, like undo the most recent change, and that's something that we built.
That's pretty darn cool.
Mm-hmm.
So one of the things when I was just reading through your blog that super impressed me is how safe you made the entire thing. Is like it was just like you had plan A, B, C, D, and E for everything. Everything was tested, the tests were tested, the tools were built. Like there's just huge investment in making sure absolutely nothing can go wrong at any point. Is that normal? Like, do you do it for everything at Airtable, or is this just this specific event was just so high risk that you made this investment?
Yeah, that's a great question. I would say in general, the Airtable engineering culture definitely puts a heavy emphasis on getting things right, especially for a big migration like this, where there is just like a huge amount of risk. Some changes like don't require the same level of like validation and testing. We very commonly deploy new features or changes behind a feature flag where you can like roll it out incrementally. So, again, maybe you show 1% of Airtable users some like new experience or like some kind of like changed behavior. And then if like things are going wrong, you just roll it back to like 0%. Unfortunately, you can't always do that when it comes to databases. I mentioned before that like the live shards, we actually are able to roll things out incrementally because we have 100 plus of them. So you can try upgrading just one shard first and see how it goes. But how about for our main shard? There's only one main shard. So you go from 0 to 100% as soon as you upgrade that shard. And the rollback there it's difficult. MySQL does not formally support cross-compatibility like downwards. So upgrade is sort of seen as like a one-way operation. We actually spent a lot of time like sort of hacking around MySQL to get downgrade working, which is very important to us because, again, having a situation where you can only fix forward is just like very scary from a risk perspective. Like there's always possibility of something going wrong that you didn't catch during testing. And then what do? You could be in real trouble.
Yeah, and it's so easy for an engineering team to, read a doc, say, okay, going back is not supported. We'll just do everything else that we can, but we're not going to plan on going back. So we'll do all the testing and everything, but we cannot go back. And yet, even though you had all the testing and everything, you still found a way to go back just in case, which I found just extra impressive. Like even though the doc said it's not supported, you guys would not give up, essentially.
Yeah, I think that I am really glad that we spent the time to build that downgrade mechanism, even though we ultimately didn't end up using it, because just our experience with like testing with our base shards was that you find some good issues when it comes to like compatibility and so on through a pre-production testing, but like production is like the real test. When you actually point production load, like the production quality workload at the new thing, that's when like the really interesting and difficult bugs fall out. And so that's why we were so careful with that main shard. Again, we upgraded our live shard first, did a lot of pre-production testing, but like even so, there is always the risk that you miss something, and having that downgrade capability made us feel a lot better about doing the upgrade in the first place.
So let's get a bit into the issues themselves. So you talked about several issues, and there was a bunch of different things, but the really interesting one that, again, I want to encourage everyone to go read because it's just fascinating. You basically had a problem doing upserting. So can you just at a high level describe what was the problem?
Yeah, I mean, I would describe this as probably the hardest bug that we encountered during this upgrade process. And again, also one that we did not catch in pre-production testing. We had to actually upgrade a live shard in production before we hit this issue. Yeah, this one was very difficult because it was something that would happen like pretty rarely, maybe like a few times per day. So it's really hard for us to capture sort of in situ, like the exact like failure mode that we are running into around this upsert bug that you're talking about. Basically, the symptoms that we were seeing was a high deadlock rate on the MySQL side. As a fellow DBA, I'm sure you also know, like deadlocks are not good. They're very expensive when you're rolling back these transactions in MySQL. So they can lead to like very serious performance issues on the MySQL side. So it's important that we figured this thing out before we actually proceeded with the upgrade. So we spent a lot of time like digging into like in the MySQL logs, understanding how our workload interacted with MySQL, and ultimately figured out that again these upserts were facing this kind of like new performance issue on the new version of MySQL. Through some very intense Googling and research, we found a MySQL bug reported on the public bug tracker that actually exactly described the situation that we were running into. And we were very fortunate that people had done like some very deep analysis of this upstart issue. And I want to call out like this one commenter who put together like, I think it was like 15 different options for how you can work around this upstart performance issue through various like database or application level changes. So we had one of our like, best MySQL experts at the company working on this. And ultimately he decided that the choice sort of came down to two options for us in our application. One, we could restructure our application to no longer use auto increment ID. Or two, we could change the isolation level of our application from repeatable read to read committed, which is a lower isolation level with like weaker consistency properties. The first option of refactoring all of our code to no longer use auto increment, that's a very heavy lift. Internally, we do try to like discourage auto increment now in favor of our own UUID based ID format, so it's sort of like a more random ID. But we still have a lot of like legacy tables, legacy columns that we're using auto increment.
Yeah, and I think I'll just call out for listeners who have not tried this before. Moving the application code from auto increment to UUID is usually not the hard part. It's all the data that is already in the database. Remember, it's all primary keys, and primary key is the one thing in the database that is supposed to never ever change. So adding to a large migration project, essentially what is another large migration project in which you change a bunch of primary keys, seems incredibly daunting at the best of times. So there are cases where you may want auto increment ID, but I think a lot of people just use them automatically without even thinking about it. And at least considering UUIDs as an option that just generate less locks because the different IDs that get inserted and updated together are not close together in sorting order is actually something you want to at least spend a few minutes thinking, do I really need auto increment over here?
Right. Yeah, I'd say that at Airtable, we actually have spent a lot of time building like internal developer resources around schema design, and especially things like you're talking about, like primary key design. Because some of these choices are very hard to fix afterwards. You can do that big migration, that big backfill, but we're at like the petabyte scale here, so that could take a while.
Yeah, I mean, you have 100 shards. Any kind of migration would be serious work for sure.
Right. Yeah. I guess like getting back to like the core choice for us for this upsert bug though. So, we sort of had looked at it again and we said like, okay, fixing like these auto increment ID primary key columns, that's, as you said, a very daunting task. But how about reducing isolation level from repeatable read to read committed? So I guess for like the listeners, like in like databases and database literature, isolation level is a very important concept. It's basically the consistency properties you as the user of the database get when you're working within the transaction. So like, I guess an example would be like, let's say, Gwen and I are both interacting with the database at the same time. And we want to like be reading and writing the same data in the same table. Like, how do we resolve like what I see when Gwen's also making concurrent updates? And that's sort of like the basic example for repeatable read versus read committed. So the default isolation level in MySQL is repeatable read. It's like a pretty strong isolation level as far as these things go. It means that when I am in my transaction and I'm issuing reads, if I read a row early on, I do some other stuff, I read that same row again, I actually get the same value. So
Yeah, even if
MySQL,
someone else did something while the transaction was in progress, you will not see what they did. You will only see what the state was in the beginning of the transaction.
exactly. So that's really nice for me as in the transactions, I have like this sort of like a snapshot, you might think of it, that I'm working in. And that means that MySQL has to do additional work for me, because again, I'm in this transaction. Meanwhile, all these other writes are coming in. The data I'm reading is being updated by other users, but I still see like the values when I first started doing those initial reads. So MySQL under the hood has to actually unwind a lot of these reads to like restore the old version for me, like this multi-version concurrency control, very rich topic in database literature. But again, so we were operating under this like pretty stringent level of isolation with repeatable read. Read committed is weaker. So read committed means that, again, I'm in my transaction, I issue a read, I wait some time. When I read again, I might not actually get the same value. So if another user has come in and like updated that row, committed their transaction, I might read that committed value. And that's why it's called read committed. You can read a committed value. So this is kind of weird. As an application developer, how do you reason about like the data sort of changing underneath you in a transaction? So we had to think pretty carefully when it came to our application, whether this would be a safe option for us, again, downgrading the isolation level from repeatable read to read committed. We were actually very fortunate that we were able to exploit sort of a unique property of Airtable's like application, which is that it's actually a very heavily serialized workload. So I mentioned before that Airtable is an in-memory database built in Node.js. That means that when we have multiple users who are all collaborating on the same Airtable base, all of those requests, reads and writes to our API are all ultimately routed to a single Node.js process, which has all of the base data in memory. And all those reads and writes go into a queue, which is serialized. So that means that at the MySQL level, there never are concurrent transactions happening on a single basis data. And you can see Gwen's nodding here. It's a very interesting, unique property.
Yeah, and I just love the idea of exploiting unique kind of properties of your application in order to optimize the database for your unique application.
Yeah, exactly. So, I mean, we talked a lot about how like in repeatable read isolation levels, like the whole thing you're worrying about is like when two people are basically working on the same data at the same time. But the cool thing about Airtable is that we just never have that happen. Again, all the requests to a base are funneled to a single process, which like processes one request at a time. So we never have a situation where there are like two people trying to write the same row or read and write the same row at the same time. It just doesn't happen for us. So it actually makes read committed like sort of a slam dunk. Just by reasoning about like how our application is supposed to interact with the database, we're able to very safely like change the isolation level.
Yeah, and the whole reason that you could even, do what is essentially a single-threaded application and single-threaded database operations in Node.js is going back to Airtable's human scale. In most other databases, people are like, so I don't get any concurrency in my database. That's kind of weird. But it looks like this just works perfectly for you.
Yeah, I mean, I would say that, Airtable started off as sort of like a human scale database, but now we have these enterprise customers that want like, tens or even hundreds of concurrent users that are all like reading and writing an Airtable base at the same time. And at that kind of scale, you can imagine that single threading starts to become a bottleneck. And this is something that we are actually thinking about improving as we, sort of develop the next generation of Airtable's database architecture. So how can we sort of like start applying well understood like database scaling techniques, things like read replicas, for instance, for handling read scaling, to like our currently like single threaded, single process database design. So we're looking at a lot of these sort of like interesting directions when think about the future of how we scale Airtable.
It looks like Node.js is on the way out. Can you share your next language?
Yeah, I'd say we are still pretty early in terms of some of this work, but it isn't that we are like working on, we want to try again scale Airtable to 10x the number of users, 10x the amount of data, things like that. And I will say that we have internally been very impressed by Rust. So we have found some situations where we can write performance sensitive code, some kind of computational kernel in Rust, and then call out to it from Node.js, and it actually works pretty well. So we have a few examples of this in the code base right now, and it's definitely a promising direction, I would say, for maybe the future of Airtable's in-memory database representation.
So if there are any Rust fans listening, and I know there are Rust fans listening, and you're interested in working on a pretty cool project, you guys can call Andrew, and
Right.
yeah, we'll put your LinkedIn, I guess, on the show notes, so people who are interested can.
Yeah, we are hiring.
Yes,
we are hiring.
So going back to the migration. So at this point, you have solved a gigantic, mysterious locking issue after, I don't know, weeks of debugging probably. And you even had a fairly successful, migration shard by shard, moving bases over. And now you get to your single point of failure, or not exactly single point of failure. We had replicas, but single point of upgrade, which is the main shard. And in order to, you did a lot to make it safe. And again, lots of details on the blog. But one of the things that you did really interesting is, again, exploit a feature of your architecture to build a pretty unique test system that I almost never see. So can you talk a bit about how you decided to test it and how you built this out?
Yeah, I think it's another sort of interesting property of Airtable's architecture. So we actually internally have a monorepo and a fairly monolithic architecture. So we do have multiple services, but all the services are written in TypeScript and have the same look and feel in terms of what libraries they use, their logging patterns, how they're deployed, and most importantly, from our perspective, the database access layer. So every single client of MySQL at Airtable uses the same access layer that's maintained by the storage team. And it means that we have huge leverage. You can imagine that at a company where there are multiple languages, multiple repos, microservices, there's just no way you can roll out a change to every single one of your database clients in a single commit, but we can do that here. So with a single deploy, we can actually change the behavior of how every single Airtable MySQL client interacts with our main database, which is incredible. And that's something that we leveraged for our record replay testing, which you were talking about, for our main shard. So we were sort of looking for a way of how do we test production level workloads against main without actually upgrading it. And that's where we sort of landed on record replay. So we actually added a little bit of code to our MySQL client wrapper to log all the queries that are being made to disk. And we put it behind a feature flag, so we were able to roll it out incrementally. So we could record 10% of reads, 100% of writes, 100% of reads, 100% of writes, something like that. And then later feed it into a replay system that we built on Kubernetes to actually test the actual queries with actual production data running against a snapshot of our main database. And this was incredible. You have to have the system turned on to be able to replay a bug that you might run into. But we learned that the recording overhead was fairly low, as it turned out, especially if you're willing to record only writes and maybe only a fraction of reads. So our workload very much skews heavily toward reads over writes. But most of the issues you find at MySQL, I would say, often are with those write queries. They're much more valuable to be recording. So we actually can leave 100% write recording on almost all the time, which means that when we do run into an issue, then we can just grab those replay logs, create a snapshot of our core database, and then like replay against our production database. And
so you actually kept this investment in record replay just going forward all the time, regardless if you have additional migrations or anything like that?
Yeah, I mean, basically, again, we learned that the overhead of leaving recording on was fairly low. Like we didn't even notice it when we looked at like our CPU and like disk metrics and Datadog. So, and yeah, this has actually been an incredibly useful capability beyond just this one upgrade. So like this upgrade was definitely the motivation for building this record replay functionality, but having the ability to run production level load in a test environment is just incredibly useful for any kind of like database or infra change that we're working on. A few examples are that, we had to do another database upgrade, MySQL upgrade recently, and we used like the same framework for the new version of MySQL that we just upgraded to. We also used it recently for some testing of Ghost. So we use this tool called Ghost for running our online schema changes. It's a tool written by GitHub. I endorse it heavily. But like we wanted to test, like, okay, so we've had problems with schema changes before when we ran production. How can we make sure that when we roll out Ghost, it's not going to cause the same issues? And we use record replay to run production level load in a test environment. Then we started running some schema changes with Ghost in the meantime. And that also shook out a few bugs that we were able to actually fix.
Amazing. And talking about your custom SQL client layer, other than record configurable levels of traffic, does it do other cool stuff?
I mean, I would say so, yes. So a little bit of backstory here is that, at Airtable, we've actually been using Node.js for a very long time. I think we've been on Node for like 10 years, maybe more than 11 years at this point. And if you rewind back to like roughly 2010 era, like Node.js, that ecosystem, it was pretty bare bones. There weren't too many people that were running Node in production in 2010 or 2012. And so we actually had to build a lot of things ourselves, including our own sort of like lightweight ORM layer, which we call a DB table accessor. And that's sort of like our thin abstraction over the MySQL JS client that we built at Airtable to really enhance a bunch of new features. So I think the most important one is probably our schema management layer. So we have our own schema management layer in our DB table accessor layer, which allows us to define like custom types beyond what just MySQL supports. So we actually have like additional like client-side validation we run for things like, is this an Airtable specific ID format, for instance? So like we have like a user ID, like a base ID, a workspace ID. We actually enforce that, this is not just a string column, this is a Airtable user ID column, for instance, in a table. And same thing for like JSON. So we actually have support for like complex types that are ultimately a string column, but validated at the application level. And this predates JSON support in MySQL. So
yeah, and I was just thinking like emails, IP addresses, there is so much you can do if you can have your custom strings.
Yeah, exactly. So, we built all kinds of our own validation logic, like application-specific validation logic in this DB table accessor layer. We also have our own migration process that sort of links into this too. So we have checks, for instance, around compatibility. So, thinking about what schema changes are compatible or incompatible, you can think of okay, so adding a column, generally pretty safe. Deleting a column, not so safe. So we can actually automatically check that the changes that you're making to the schema are compatible by using our automated test suite. So by having our own schema definition layer that we built on top, we can utilize that information in these interesting ways.
That's amazing. Definitely looks like anyone who uses a database at Airtable just gets a better experience than anyone using MySQL anywhere else.
Well, I mean, I'd say these days, if we were starting from scratch, I'm not sure we would have chosen to build our own ORM layer like this. It is pretty complicated at times, and there are some gaps in functionality. But back in 2012, there was no other option. We sort of had to build it ourselves. And overall, I'm pretty satisfied with where we've gotten in terms of integrating it with all these other kinds of processes that we run internally around the database.
Yeah, I'm just thinking, like, if you had to pick if something even today, I don't know, I think maybe the state of the art would be something like Prisma, but it would still have, seems like it just, there's a lot of stuff that maybe Prisma does and you don't, but there's also, it seems like tons of stuff that you do. And if you choose Prisma, you now have to figure out how to bake it into an ORM, essentially.
Yeah, exactly. I mean, I've looked at Prisma a little bit, and I think that the team seems strong. The ideas seem good. But at the same time, like for us and where we are, I don't think it's worth migrating most likely because we have things very customized to Airtable. I mentioned before, we have our own like client level like validation framework for these custom data types. We need to have that on Prisma. We have it sort of working a certain way for how we run migrations internally. So I think that like off the shelf, you get a lot from Prisma, but you probably still need to spend time actually integrating it to how your engineering team like wants to interact with the database.
Yeah, it feels like this is always the case pretty much. No matter what you pick, at the end of the day, your team works in a specific way. So we're running at time. So I'll ask you, like, to finish off the show, let's put the migration experience aside for a second. Everyone, you have to go read the blog. And it's very obvious that your storage layer is super impressive. So if someone were to, I have a new application, I have a new product, new company, I'm starting things from scratch, what kind of advice do you give them? Like when it comes to, I have to design my database?
Yeah, that's a great question. Something that, I do think about as like the manager of the storage team here. I would say that Airtable, when we started in 2012, we made the choice to pick like a reliable, stable, well-known technology for like the core of our database architecture, MySQL. And it's worked pretty well overall. We had to build a lot of tooling on top. The operational load can be high at times, but we managed to go for like at this point, I think 10 years with a relatively simple database architecture. Like the patterns for how you scale some of MySQL are well known. We're definitely not the first company to be doing like application level sharding or things like that. So, I think pick something that you think is stable, reliable, and has some proof points in the industry. That said, though, in my past experience, I've worked actually with like MongoDB and had a positive experience. We also use Dynamo here at Airtable, and that's also been very positive. So ultimately, I think it really matters like what kind of skill set you have at your company. What are you familiar with? So if you have a lot of developers that have experience with MySQL, probably a good choice. If they're better with like Dynamo or MongoDB, probably should go with that, because especially at like an early stage company, I think developer velocity, developer efficiency is sort of paramount. You don't want to be spending a lot of time like learning how to like do what you want to get done with your database.
So yeah, that makes a lot of sense. And in general, doing the things that your developers are strong at seems like gives you better chances of success. Mm-hmm. So yeah, Andrew, thank you so much for joining and talking about your experience. It's been very educational.
Yeah, my pleasure. Thanks for inviting me on the show, Gwen.